Look closely at this image. Almost every speck of light you see is an individual sun. There are more than 60 million of them packed into this single frame. You are looking directly into the galactic bulge. It is the swarming, chaotic heart of the Milky Way, a region so bright that it typically floods the sensors of most telescopes. The machine that captured this is the Euclid Space Telescope. Euclid was designed for the dark. It was built to look away from our galaxy, toward the deep, empty patches of the universe, to map invisible dark matter. But for 26 hours in March 2025, astronomers aimed at somewhere it was never intended to go, the most light-polluted region of our entire galaxy. Despite having the sharpest view ever taken of these 60 million stars, Euclid did not discover a single new planet in this image. In fact, it wasn't even looking for them. Instead, Euclid created a locked archival record. It captured a before picture of the galaxy, intended for events that will not happen for years. Astronomers are hunting for frozen, distant worlds that circle in the dark. They find them using a technique called microlensing, which relies on gravity rather than light. A nearby star drifts directly in front of a distant background star. Its gravity physically bends the light behind it, acting like a magnifying glass. If the foreground star has a planet, it adds a tiny tug to that bending light, revealing a hidden world. To catch these alignments, ground-based telescopes have to stare at the most crowded star fields imaginable for decades, simply because more stars increase the odds of a collision. But there is a bottleneck. During an alignment, the two stars blur into a single light-saturated smear. From the ground, it is nearly impossible to separate them or calculate the planet's actual mass. Detection is not the same as understanding. Without a way to distinguish the light of the foreground star from the background, the planet remains a ghost in the data, present but impossible to weigh. Euclid changes the math. Its sensors see as sharply as the Hubble Space Telescope, resolving densely packed stars into distinct, clean points of light. But while Hubble zooms in on small targets, Euclid captures massive sections of sky. Each of its images covers an area 270 times larger than Hubble can see at once. Hidden in this specific frame is a frozen world, often compared to the ice planet Hoth. An astronomer has waited 20 years to measure its mass, but the stars were always too crowded to see clearly. There is also a rare binary system here, two stars orbiting each other with a single planet. For years, they have appeared as nothing more than an unreadable blur. Euclid's new data finally separates the light. It resolves those blurry smears into separate, distinct suns, allowing astronomers to see exactly what they are looking at. And by taking this ultra-sharp picture now, Euclid photographed all of these stars now, sharp and clearly separated, before any of them line up. This is a handoff. In the coming years, the Roman Space Telescope will spend its entire mission monitoring this exact patch of sky, waiting for microlensing events to happen. When Roman eventually catches a star brightening, astronomers will reach back to this Euclid image as their baseline reference from the past. By comparing the blurred alignment against Euclid's pristine before shot, astronomers can calculate the speed and motion of the stars. This provides the missing data needed to finally weigh the planet. But step back from the mechanics for a moment and look at the scale. Every point of light in this frame is a sun, many not so different from our own. Statistically, we expect almost every single one of those 60 million suns to hold at least one world in its orbit. We have no proof of life here. We may search for generations and find nothing but ice and rock. But look at the sheer number of solar systems in front of you and ask yourself if every last one of them is barren. The real weight of this photograph isn't the 60 million stars we can see. It is the near certainty of the hidden worlds we haven't even found yet.